Greetings, scheduling savants and efficiency enthusiasts. Ernis here, ready to drag you kicking and screaming into the fascinating, and often frustrating, world of optimization. Today, we're cracking open a juicy paper titled, Discovering Heuristics with Large Language Models. LLMs, for mixed, integer programs, single, machine scheduling. Now, I know what you're thinking. Ernis, that sounds drier than the Sahara. But trust me, there's some seriously cool stuff brewing under the hood. Imagine you're a cosmic air traffic controller, juggling a fleet of spaceships, each with its own unique arrival time and deadline. Your mission? To schedule these ships so that as few as possible miss their window. This, my friends, is essentially the single machine total tardiness SMTT problem, a scheduling nightmare that plagues industries from manufacturing to, well, space travel, I suppose. The core problem here is NP. Hard. Translation? It's brutally difficult to solve perfectly, especially as the number of spaceships, tasks, increases. So, what do? We turn to heuristics. Think of them as clever shortcuts, little tricks that get you a good enough solution in a reasonable amount of time. This paper is all about using large language models, like the ones that power your favorite chatbots, to discover new and improved heuristics. Yes, you heard that right, we're teaching AI to write its own problem-solving strategies. Now, let's step into my mental memory palace, shall we? It's a sprawling observatory, filled with blinking consoles and star charts. In the first room, we have the specification engine. This is where the problem, our SMTT challenge, gets translated into a language the LLM understands. Think of it as writing a cosmic instruction manual. The researchers used what they call prompt engineering to guide the LLM, essentially whispering sweet nothings of optimization into its digital ear. Next door, we find the LLM agent. This is where the magic happens. The LLM, armed with the instruction manual, starts spitting out candidate heuristics. It's like a cosmic chef experimenting with different recipes, some delicious, some utterly inedible. But don't worry, we have a sophisticated palate. And that leads us to the evaluator, our third room. This stern judge puts each heuristic through its paces, testing it on a mountain of scheduling scenarios. Does it minimize tardiness? Is it efficient? Only the worthy algorithms survive? Finally, the successful heuristics are stored in the program's database, a vault of algorithmic gold waiting to be deployed. So, what did these LLMs actually discover? The paper introduces two new heuristics, EDD Challenger EDDC and MDD Challenger MDDC. These algorithms build upon existing methods, but with a twist of AI magic. The EDDC algorithm is like a cosmic janitor, sweeping up the tardiness left by the original earliest due date. EDD rule. It focuses on swapping the last two jobs in the schedule if it reduces overall tardiness. Simple, but surprisingly effective. The MDDC algorithm, on the other hand, is a bit more sophisticated. It iteratively schedules jobs based on a complex scoring system, constantly recalculating scores until all jobs are assigned. Think of it as a cosmic chess grandmaster, always looking several moves ahead. Now, the juicy part. How do these AI discovered heuristics perform? The researchers ran a ton of experiments, comparing EDDC and MDDC against existing algorithms, and the results? They're, well, pretty darn impressive. In many cases, MDDC outperformed existing heuristics, especially on larger, more complex scheduling problems. It's like discovering a new, faster route to Mars. The EDDC algorithm also held its own, proving that sometimes, the simplest solutions are the best. Now, fine, yeah, I guess. Look, the paper isn't without its limitations. The LLM discovered heuristics aren't always the best, and their inner workings can be a bit opaque. But here's the real kicker. This study demonstrates the power of using AI to automate the process of algorithm design. Imagine a future where we can unleash LLMs on all sorts of optimization problems, churning out a constant stream of new and improved solutions. What does this all mean? It suggests a future where AI collaborates with human experts, pushing the boundaries of what's possible. It's not about replacing human ingenuity, but about amplifying it, creating a synergy between human intuition and artificial intelligence. So, the next time you're stuck wrestling with a scheduling puzzle, remember the EDD Challenger and the MDD Challenger. Remember the cosmic air traffic controller and the tireless AI chef. And remember that the universe is full of mysteries just waiting to be optimized. Until next time, keep exploring, keep questioning, and keep those spaceships on schedule.